Let's take a look at how we draw ray diagrams and locate images for our converging and diverging lenses. Similar to our mirrors, we have to first start off by labeling all the special points along the principal axis of our lens. So if we start on the left, and we're going to assume that the light is going to be coming in from left to right here. So on the left, far left side, we have this point we're going to call 2f prime. I mean, we have f prime. In the middle, we have O, the optical center, and then we have F, focus, and then 2F. So F is the focus, 2F is just twice the distance from the focus. F prime is the same distance from the focus, but just on the side that the light's coming in, and then 2F prime is twice that distance. In terms of our rules for the ray diagrams, in this case we only have 3 as opposed to the mirrors where we had 4. And the rules are going to be very similar. So the first rule is that any light that comes in parallel to the principal axis is going to make contact with our mirror, and we're going to simplify our lens. We're going to simplify our lens by this vertical dotted line. Comes into contact with the lens, and then it's going to go through F. So that's our first rule right there. The second rule is that any light coming in through F prime, making contact with our lens, is going to come out parallel. So like this. And the very last rule is that any light that passes through the optical center, O, will continue straight through the optical center. So just like that. Let's take a look at the case where we have an object located beyond 2f prime, so on the far left side of our diagram here. So the first rule, as always, is going to be take a line that comes parallel, makes contact with the principal axis, and then goes through our point F. The second rule is that if we have a line that goes through F prime, makes contact with our lens, it's going to come out parallel to the principal axis. The last rule is that any light coming from our object going through the optical center will pass straight through the optical center. So if we look here, we have exactly what we anticipate, is that all 3 of our lines have intersected at the same spot. Now, they might not always intersect exactly at the same spot, but they should be pretty close. So our image is going to be over here. And if we compare the image and the object, we can do our SALT table. And in this case, the image is smaller, inverted, located between F and 2F, and it's a real image because it's made up of these solid lines. The next example is the case where we have the object located exactly at 2F prime. So if we follow the same rules from before, we're going to start by drawing a line that goes parallel to the principal axis, makes contact with our lens, and then travels through F. The next ray is going to start at the object, travel through F prime, make contact with the principal axis, and then continue parallel. And the last line is going to start at the object, go through O, and continue through O. So we can see here that it looks like our object and our image produced is somewhere about 2F. And that's exactly where it's supposed to be. If we were to compare these with a ruler, we'd see that the sizes are exactly the same. Obviously, the image is inverted. It's located exactly at 2F, and again, it's a real image. The third case here is when we have the object located between 2F prime and F prime. So as you can see, we're getting closer and closer to O. So we're going to start again, as always, by drawing a line that's parallel to the principal axis. That line makes contact with our lens and passes through F. The next line we draw is going to pass through F prime, make contact with our lens, and then come out parallel. The last line is going to start at the object, pass through O, and continue on as far as we can draw it. So this one, they're getting a little bit trickier here, but for this one, we can see that the object is going to produce an image slightly after 2F. This image is going to be larger, inverted, because it's upside down, beyond the point 2F, so anywhere to the right of that, and is again another real image. For this case, we've now moved our object directly on the point f prime. If you remember from our mirrors, usually weird stuff happens when we have an object at the focus point. So we're going to start, as always, by drawing our parallel line. That's then going to go through F. We're then going to draw the line through F prime, but obviously we can't, because we can't draw a line that goes through F prime, but then also goes through our lens. So we can't draw that one. That should give you a hint that something untoward is going to happen here. So we only have one other option. We draw a line from the object through O and passes right through. And it looks like these lines are going to be parallel. And of course, indeed, they are. So for this particular case, what we say is that because the lines here are parallel, that there's going to be no image formed. Parallel lines can never intersect, meaning that we're never going to be able to form an image over here. The last example we have is when we have an object located between F prime and O. So somewhere getting closer to the lens, and obviously staying on the left-hand side. So let's follow all our rules as we normally would. We're going to draw a parallel line, and then we're going to draw one through F. We're now going to draw a line that goes through F prime, but we can't because F prime is behind the object. So we can't draw that one. We're going to draw a line that goes through O and passes right through. And again, here we've got an issue where these lines, now they're not parallel, but they are diverging, meaning that this one's going to continue on this trajectory, this one's going to continue down there, and they're never going to intersect because they're moving further and further apart. So what we have to do in this case is draw a set of lines that's going to come back behind the lens. To do that, we're going to follow the line we drew, and we're going to take it back as far as we can. So probably maybe somewhere over here. Same thing with the blue line, which is the one that goes through O. So we're going to take this line, and we're just going to follow it back as far as we can. Great. So here we look like we have a virtual image because we're made up of these not real lines. And remember that we're using a faded line here, but you should be using a dotted line. And when this is the case, we have an image that's larger, it's upright, so same direction as the object. We just say it's behind the lens. We don't need to specify if it's between 2f prime and f. It's just going to be somewhere on the left-hand side behind the lens. And because it's made up of these faint lines, or probably in your case dotted lines, we're going to say it's a virtual image. The second lens we have is a diverging lens, and you should notice right away that we've flipped where f prime and f, and then 2f prime and 2f are. So now f and 2f are on the left, f prime and 2f prime are on the right, but our light is still coming in from the left-hand side. So we're going to start just by drawing a line that comes in parallel to the principal axis, and then it's going to hit the lens, and we're here unsure where it's going to travel. So what we're going to do is we're going to draw a line starting at F, and this is going to be kind of a working line for us to show us where the light is going to travel after it hits the lens. So all we need to do is go over the top part and make that a solid line. For the second line we're going to draw, we're going to have the light coming in, but headed towards F prime. So we're going to pretend as though the light is going to pass to F prime, but of course we know that that's not going to be the case. So what we're going to do now instead is we're going to redraw the portion on the left with a solid line, and we're going to then extend that parallel to the principal axis. The third and final line is going to be the same as always, which is a line that goes through O, will just pass through O. So in this case, we're just going to identify here that we have a working line here, and we have a working line here. So we don't really use those when we're going to start coming up with our images. Okay, so determining where an image is going to be produced for a diverging lens is a little bit more complicated. There's only one possible solution here, unlike the 5 from the converging lens, but it's a little bit trickier to come up with an accurate image. So we're going to start off just like we normally would. We're going to take a line that comes in parallel to the principal axis from the object. It's going to make contact with our lens, and we're going to draw a working line just to give us an idea of where the resultant ray should go. So it's going to come out like this. Okay, great. And we're going to just solidify the one on the right hand side just to show us that this is truly where the light goes, and the faint part on the left, so this part right here, is just a working line for us, and we could actually even get rid of that if we wanted to. The next line we're going to draw is the one that looks as though it's going to pass through f prime. So we're going to start at f prime and we're going to draw a working line that looks like this. We're then going to go over it with a solid line to show us that the line will come in towards the lens and come out parallel to the principal axis, something like that. So just again, remember that this portion right here really isn't of use to us anymore. It's just to show us how we came up with this first line. The last line we're going to draw is going to start at the object and pass straight through the optical center. Okay, so we can see here that on the right-hand side, we have 3 lines that have not intersected anywhere. This is, of course, because this is a diverging lens, so the lines are not going to intersect on the right. What's going to happen, though, is we're going to do some work on the left, somewhere over here, and this is where our lines are actually going to intersect. To give you another bit of a hint, is it's going to intersect somewhere along this blue line. Okay, because the blue line we didn't have to draw any faded or dotted lines for, we know that this one is going to work out for us. So the answer is going to be somewhere along this blue line. There's 2 ways to do this. The first one is to just go over the red line we've drawn. So this one here will be of use to us. And we can see here that they do indeed intersect at this point. You should be asking yourself, well, the green line isn't intersecting there. And that's right, because what we have to do is we have to take back the green line, but parallel to the principal axis. And if we do that carefully, we see that the green line also intersects at the same point. So all 3 lines have converged on the same point, but behind the lens, meaning that this is where our object is going to be, or the image is going to be from the object. And the answer here is that it's a smaller image, it's upright, it's the same side as the object. We don't need to denote that it's between F and O, we just say it's on the same side as the object. And because it's made up of these dotted or working lines, it's a virtual image. So here we've just got a little bit of a summary showing you all 5 cases for a converging lens in the top table, and the one and only case for a diverging lens at the bottom table. Thanks for watching. Make sure you like, get subscribed, leave a comment below, and check out our suggested videos. Make sure you hit the bell icon so you don't miss any future updates.